Yeah, thank you. Let's start. And yeah, I think this talk for people who completely new with Flutter and haven't write any line of code will be a bit complicated, but we will start from the easiest thing and go to more complicated. So hope it will also be bearable. But yeah, the main thing which we gonna talk about today is not the visible work of Flutter, but invisible work of Flutter, because between those steps when we write some Dart code and users see pixels on the screen, there are a lot of work done, and this work done hiddenly. So it's good to know what's happening exactly, and especially it's good in the current situation when a lot of code is written by LLMs, and we need to understand if this code is good enough to keep it, or it's better to replace it. So internal mechanism in Flutter's really important. But yeah, let's start from the short introduction. My name is Mikhail Zotyev. I'm a software engineer with more than a decade experience, and the last 6 years I completely focused on Flutter. Work with this the majority of time as a professional developer and as an enthusiast as well. So I'm being a Flutter GDE, organizer of meetup community in Voronezh. Flutter Voronezh. So like and support open source, maintain a few personal projects, and also take part in the other projects, including Flutter by itself. And as was already mentioned by Anna, that I am an author of the channel, educational channel about Flutter, All My Flutter. So you're welcome to join. And also on the slide, you can see my nickname, which you can use to connect with me in any social network which you prefer, and where registered, of course. And on that note, let's move to our main topic. And our main topic is Flutter. And let's start from the really brief overview of Flutter as a technology. And depends of the time what we're talking about, the Flutter was described in a completely different way. So in the really beginning, the like most complete description was a declarative UI framework, something like this. And then we got good enough support of two platforms, not only one Android, but also an iOS. And in that time, people start describe Flutter as a cross-platform framework. That is was already good. And currently, apart from those two mobile platforms, we have a web support, we have a 3 desktop and embedded devices. So we can fairly say that Flutter became a multi-platform solution. So multi-platform that even if there is some platform that is not properly still supported, you can run Flutter on it. You can check a talk from Sasha Denisov, in which he describes how to run Flutter application on Apple TV and Android TV. So both are not supported efficiently, but you can run a Flutter application there. So even something not supported, put some work, and you will be able to see Flutter application there with the one requirement to have a screen. And regarding screens, I also like one quote from the Flutter website. I'm not sure is it still actual on the website or already not, because it's marketing quote. They are also changing time after time, but this one is my favorite one. It says Flutter allows you to control every pixel on the screen, and it's true, because with the Flutter you definitely can do this. But why I like this quote, that at the same time it's really funny that when I think about mm, this goal to control every pixel, I think about really complicated stuff like a cockpit in a plane. So where you need to know so many things to properly drive it. But Flutter, it's still being a declarative framework. So it's quite easy. You just describe what you want to see, and you will see this on the screen. So instead of this complicated stuff, you work with the really straightforward stuff, just describing what you want. And let's move to the next step in our today's talk and think about how to build UI, how to describe this UI. So I would like to offer you to think about this problem not from the perspective of Flutter, but in general. So what I need to do to properly describe the user interface. From my point of view, I need to answer three simple questions. What to show? Is it image? Is it button, label, or something else? Where to show? How they connected to each other? Where this image located? Is it in up bar or in a card or somewhere else? And how to show? Which size, position, maybe additional color or something effects. So answering these three questions, we can properly describe a user interface. And Flutter delegates answering on those questions to three entities. It's a widget, it's element, and it's a render object. Let's follow them one by one and check their responsibilities and what they are actually. So first of them is widgets. And even if you work a few days with the Flutter, you definitely have uh, heard this quote already. It's all widgets. And even if we already know from the previous slide that not everything is a widget, it's still a central class in Flutter framework because we can create our own elements, our own render objects, and so on. But what's important, we will never work with them directly. To work with them, we anyway need to work with a widget. So widget is an immutable description of part of user interface. So some kind of intention to show something. And here on the slide, I put this item in this list with the asterisk because it can be a bit questionable point. First of all, people can say that and how is immutable if we have, for example, state, which is completely immutable, is changing during time. We can set the state and change the visualization. Yes, state is mutable, but stateful widget by itself, it's still immutable because state is not related to stateful widget. Stateful widgets create, state delegate every work of of this subtree to this state, and then do nothing apart from this. And the second thing is that user interface by itself is not static. It's kind of mutable things. It's always changing. It's can play animation, content inside can change always. We can download some information and from the loading state moving to the content state. Different transformation on the screen happen. And yes, to answer this, Flutter also uses some interesting approach. So during lifetime of a user interface is completely immutable. But if we split this time into really small pieces of time, which will be almost immediate, like a moment of time, we can fairly say that in this moment, the user interface is completely static because it's how our devices work. They show us frames, static images that change one by one. So the same with the Flutter. So those immutable description describe the exactly those static state of a user interface. And then next time it's already next frame. So we will take the basis from the previous one, but replace what is not necessary now, what is outdated, and create a new part of description that is needed for us. So single instance of widget can be included in a tree one time, many times, or not included at all. So it's because of the widget by itself, it's our intention to show something. And since they are immutable, they are lightweight, they don't have a life cycle, they're just a description. And every time when we try to put this widget into place, it's inflated to an element. So the good analogy for widget is a blueprint. Blueprint in this case describes what you want to build, like some schema of this thing and so on. And using one blueprint, we can create as many objects as we want. Yeah, so the same in Flutter with widget. Let's have a look at this example. And this example is shows something different that we usually do in our normal development. We can check what happened. So first of all, we have a widget, quite a normal one. It's just a widget that represents the text "Hello World." But what's different from regular development? We create a variable and put into this variable one instance of this widget. So final my widget equal creating this instance. And then we use this instance 4 times in a column. So what happened? And we will see 4 texts, hello world. So exactly the same representation of this widget, but use it 4 times. And it's happened because exactly that we already mentioned. Every time when we use intention to show something, it's actually transformed to a real object, element. And element is a instantiation and representation of this blueprint that we wanted to show in a particular location in the tree. So because of this is a more tangible object, we can say that they are already form a tree, a real tree. And because of the same, they have a life cycle, because from frame to frame, those things more stable than widget. And during this lifetime, the widget which is associated with a concrete element can be changed. So what is a life cycle of element? Let's check which stages element goes from the creation to destroying. And first of all, yeah, we need to create element. And who apart from widget can more accurately say how to represent this widget. So widget is responsible for creation element. There is a method create element that belong to each widget. And because of this, every time when we try to insert this, we call Flutter calls this method, and representation of widget is created, always a separate one. But when it's created, it's almost nowhere, so it's not inserted yet. And to insert this into the tree, inflating, it's a stage when it's happened. So on this element, call a method mount in which is passed the parent element with which it should be connected, and the slot in which it should be placed. So after this, we can say that creation of element, so from scratch, is done. And at the end of the frame, user will see something that we created on that step. But on the next step, on the next frame, it can happen that we decide to update some part of the tree. For example, we decided that that was spinner that's loaded, like showing this loading, and then we have a content, and we decided that from this time we don't need this spinner, we need to show a content. So because of this, updating happens. So from some point we start to actualize a tree, saying that uh, we need to update this part of tree, and this can be different ways. So it can be like completely almost without rebuild if it's the same instance, or it can be done that's way that there will be only links update, or maybe we just replace the whole subtree and build it from the scratch. We will see all those examples more close in the next part of this talk. But the important thing that the decision of can we update this part of tree or not is happen also in a widget in the method which can update, which is returns for previous and old widget, comparing like do we can or not. So if we decide that this part of subtree should be updated with the removing old thing which we already used. So for that removed part, the activation is called. Why it's not destroying immediately? So for possible reusing those part in a different place, it can happen if this subtree is marked with a global key. With the global key, we can use the same global key in a different place. And instead of creating from scratch, if we have deactivated subtree, its deactivated subtree will be just moved to a place. This way, the reusing mechanism is managed. But it's worth to mention that it's first of all quite expensive mechanism and dangerous, because global keys shouldn't duplicate each other. And if you do that, there's two global keys immediately simultaneously shows in the tree, there will be an exception. And if we have some elements, some subtree deactivated, and till the end of the frame building, no one reused this, they can be properly destroyed. And since we talk about element, it's also time to talk a bit about build context. First of all, build context is a element, or even more accurately say that it's a contract which element implements. Even by the name of this interface, we can say the reason why it's necessary. So when we want to build subtree, we need to understand where do we build subtree. And because of this, we need to hide from elements some internal implementation part that shouldn't be manipulated, and highlight other part which necessary to understand where we build in this subtree. So where's the location and how to interact with the other part of the tree. Why do we need this at all? So let's start from the real world example and then move to Flutter. So let's say that I have a blueprint of some propeller, and this propeller is just thing with a few wings, right, and spinning around the axis. But based on where I put this and which environment, it can serve to different purposes. For example, if I put this in front of me and just turn it on, make it spinning, so it will be some kind of cooler. Currently it's warm, so it will be help me to cool down a bit. But if I put this into a container and again turn it on and put the milk, ice cream, and so on, it will be a blender. So the same instance, the same blueprint in a different condition works different purposes. So in Flutter, the same. In this example, we again have some widget, which is a representation of square by like 100 by 100, and with a color that depends on the theme, color theme. So what's happened if we again create the one instance of this widget, put into the variable and put it to the different place? So if we run this, even the same instance of widget works differently in a different place. In one case, it's a blue square. In another case, it's a dark gray square. So because our intention to show this subtree is just an intention, and then we start to build this representation in a concrete place. So we create elements, which is a root of subtree which we want to show, and then it's requires some information from environment, color from them. And in one case, it found the blue color, and in another it's a gray color, and because of this they work differently. And since we already talked about this working in a concrete place and so on, it's worth to mention things which we already briefly discussed. State. So as I mentioned previously, state is some kind of delegate in which stateful widget delegate the whole work. So it says I can create a special object which will care about everything else. Uh, so in this case, the same example, we have a currently stateful widget, and this stateful widget is delegate work to my widget state, which is changing its color when you click on it. And if we create the again variable with the one instance and use in a different place, they work independently from each other, because every time it's not only element created in this case, but also a separate delegates created. And element in this delegate, they are binded together, they work together, they are connected by their life cycles and so on. But stateful widget even doesn't know which state and element exactly instances represented it, because it can be 2 of them, 100 of them. The widget by itself doesn't have a link to element or state. State and element has a link to widget, but not in the other way. So based on all those things, all elements can be separated into two big different groups. One of this group is composition elements or component elements, which are work as a representation of subtree. We almost all time work with them directly and create our own type of this widgets, like stateless, stateful, and so on. And the good sign that we talk about this type of widget, that there is a method build which takes build context, and return a widget. It's a representation. So these widgets, they are just combine the subtree with the other widgets. And oppositely to those composition style widgets, there is a render object widgets and elements that have a render object that can show something. And those we have a lot of them in our framework, but usually they are smallest part of our UI. For example, columns, size box, padding, and so on. That they have some kind of layouting, and based on those two type of widget and elements, we have a approach in Flutter that call aggressive composability. What does it mean? So widget by itself, they can compose a result of what they represent with other widgets. And those other widgets, they also can be a composition of other elements. And it's going deeper and deeper before we faced render object widget that can actually represent some visualization for user. And we always know that despite how long this subtree will be, how deep it will be nested, anyway, there will be at least one render object widget. So there will be render objects for represent something to user. And render objects, they are responsible for layouting, for painting protocols. That's important to understand that they do not paint anything, they do not render anything actually, because rendering happen in a different layer, and they only calculate things and describe the result of this calculation. They also form a tree, but there is no strict rules of child model, for example, should be their child or how many of them. Maybe it's many children, maybe it's zero child at all. So they also do not have a strict coordinate system. If you want, you can work with a polar system if you want, or Cartesian. And the layout protocol is also as a something that you can choose. For example, there are two protocols which widely used in Flutter: box protocol and sliver protocol for sliver for scrolling. So if you need something for your concrete purpose, you can create your own protocol and build the out on those rules. So to sum it up, those responsibilities which we discussed, they are spread between those three objects. So for declaration and for describing what to show widget, for actual managing structure element, and for layout sizes and so on, it's a render object. But when we talk about those three things, quite often they mentioned like a tree, like widget tree, element tree, and render object tree. Let's have a look closer on one interesting thing, because we are working in the area which is a technical area. Usually when we drop some name, we have a ground under this name. So what actually this name mean? And tree, in this case, it's definitely a tree from graph theory. So tree is undirected graph. We can say that between two vertices, there is only one path, and there is no cycle, there is no loop in this graph, and so on. And when we say widget tree, it's not actually a tree, because let's have a look on at the example that we already had before. So if I create widget, put this into variable, and then use this variable many times. So it means that the one node is represented 2 times in the tree. It's not possible with the definition of a tree. So what is it? Is it not tree? Yeah, it's not tree, but it's a simplification to operate with this structure also as a tree. So it's a just declarative structure that can be converted to tree, not being actual tree, because you cannot see a relation between nodes. You cannot operate with these nodes as you want, but it's always will be connected. It's not even can connect it. It will be connected, because we will create elements for each of those widgets, and those elements, they are already built the actual tree. And let's try to stand in the shoes of Flutter and build those trees. For example, someone tried to insert this widget somewhere in a tree. So we got this widget and want to insert this. It's just a container with the red color, 100 on 100, and inside there is a text. Text is provided with the value. So how it will be? So first of all, Flutter starts with asking my widget, let's represent yourself, and this is stateless element. Stateless element connected with the previous, which we don't see here, that has a link to widget which is created, and then stateless element knows that there is no render object. It's a composition element. So it asks my widget, so build your subtree, and we already know that it's a container which wraps text widgets. So yeah. And the next thing is representation of container. And Flutter asks container, what are you? And it's also stateless element. So those two stateless elements connected to each other. New stateless element has a link to container, and again, no render object. So we need to build a representation next. And despite that, in our case, we just say that it's container wrapped around text, we should take in account that container by itself is also complicated logic inside. So the build method, which will be called, will return in those combination of parameters also subtree, constrained box, colored box, and all those wrapped around our text. So the next step, Flutter asks container constrained box to represent itself, and this is single child render object element. So there is a connection between elements, links to widget, but then this element knows that for represent itself, it's necessary to have a render object. And single child render object element asks constrained box like, what is your render object? And when it's get, it also has a connection to render object, and render object connected with the previous one. And moving to the next step. Again, creating an element, connect with the previous, has a link, again, render object. So Flutter asks about render object and make links between render object and element hold a link to render object that's created. The next step is a text that we provided in our widget. So it's again stateless element, and Flutter makes a connection, has a link, element has a link to text, and there is no render object. We need to build a subtree. So stateless element asks text, what is the representation? And then representation is a rich text. And rich text is a representation of subtree, which Flutter start asks like, well, represent yourself. Single child render object we get from rich text. We have a connection between our subtree link to rich text, and this is render object, and this render object widget, and element asks representation for render objects. And here is a render paragraph which is connect with the previous one, and this way we wrap this subtree completely. So we finished our subtree with the leaf, which is render object widget. And we also mentioned that all elements, they are built context, so they implement this interface. But in this interface, there is an interesting property, getter render object. But what happens if we, for example, ask my widget, it's a representation, it's element about get render object. So what's happening? There is no render object, as you can see here, right? But we know that with aggressive composability, at least the end of this will be render object. So at least one will be. So we will ask one by one those nodes. This one is not render object. This one is not render object, but this one is render object. So this render object will be representation for this element as well. So here's how it's done. So we have a visitor which goes from one element to another and finding this render object when it's necessary. But it was only creation of our subtree. But apart from creation, we also have an update. An update can happen with three different ways. So first of all, it can be the same instance of widget, which is returned instead of replaced replacing. It's can be the same type of widget but different instance, and it can be completely structural changed. So let's have a look on the first one. For example, if we mark some subtree that we want to update this, decide this, but then we return the same instance. How it can happen? For example, const widgets. When we have a const widget, we have a situation when it's exactly the same instance. So stateless element check that a new representation is exactly the same instance of that was before. So it's definitely nothing has changed. And because of this, it's just update a link and do not do any work apart from this. But if it's not the same instance of widget, we need to decide can we update or not. And the responsible method for this is can update, which we already mentioned. So in this method, we just check its old widget runtime type and new widget that equal to each other. If they are equal, that's exactly the same type of widget that we can try to update, and checking the keys. If they are equal, that is exactly the same, or if not, we can drop it. So let's have a look at example when we have a built subtree, the same which we did already, and the root of this subtree is updating with a new instance of widget. What happened? So stateless element check the instance and not the same instance. So because of this, we just expecting that possibly changes in the subtree. Let's update it. So can be updated. Yes, it's the same type of a widget. My widget and my widget it can be updated. So link with a new one. But then we need to build a subtree to decide what's happening inside. So we know that it's container around the text. The next stateless element has a link to container, and new widget is also container. So the same type can be updated. Again, need to build subtree. Subtree is built and move to next level of this subtree. So we have single child render object element. It's connected to constrained box, and the new widget is constrained box. Same type can be updated. So it's a render object widget. So possibly there is a change in a render object widget, but in our case it was hard coded 100 to 100. So we can fairly say that there is no changes in this case. So we don't need to touch render object at all. The next step again has a link to colored box. Again, colored box we can update. Again, render object, we need to check is there any change, the same type, the same color, it's hard-coded in our case. So there is no change in render object. And next step is again just a text widget. The same type can be updated. We just update the link from element to widget and need to build a subtree. And subtree in this case rich text with the text B, for example. So what's happened next? So single child render object element has a link to rich text, and currently is also rich text, so they completely backward compatible. So we can just connect with a new widget. But this render object widget has a update of a property, because previously it was rich text with the text A, and now it's text B. So because of this, render object also should be updated. And after we finish this, we completely updated this subtree. Sorry. Let's move to the next case, which is structural changes. If we have structural changes, things more expensive from performance wise. And what's interesting that we can make these structural changes without intention. For example, let's have a look on those examples. Exactly the same widget that we have before, but in this case, we decided to make a small refactoring. So we also take a color and use this color in our container. So we just passing color that is passed to our widget. Not so big change, right? But what happens if our current, again, the same initial state is updated with another instance, my widget instance B, but color is null. So the beginning the same, so it's not the same instance, but the same type. We can update, build subtree, and again we can update and need to build subtree. And then, because of property changed, container calculated subtree like a bit different. So we have, instead of constrained box and colored box, only constrained box. And the first update on this level will be again similar. So single child render object element, check the constrained box type, it can be updated, no changes on sizes, everything fine. But the next things, we had single child render object element, and currently it's something different. So it connected to colored box, and we want to connect it with a text. It's not possible, they are completely different. It makes no sense to keep them. So because of this, all those subtrees will be removed, and we will continue from this point, like building from scratch, create a representation, connect them with the previous one, connect with the widget, try to build subtree, create representation for this subtree. After this, create a render object for those widget and inserted this again. And after all those work done and the end of the frame, we also need to remove destroy all subtree which we already removed from the screen from here. And decision of can be subtree updated or not, as we already discussed, is done by this method can update. And in this method, we also can rely on key. And in our case, we didn't use key in example, but it's possible that if there is a key provided, we need also to check them. And key is a special object to identify some subtree. And they can be sorted in two types: global key and local key. Local key work on a one level. For example, if we have a column, row, or scrolled area, and this with a multiple objects placed in the one depth of tree, we can use those things to identify. It can be helpful for sorting. It can be helpful for removing something from the middle to correctly identify what was removed. But apart from them, there are global keys. And global keys, it's a special object which works across the whole application. So they identify subtree as a unique for entire application. Because of this, we have a beneficial thing. We can directly, with this key, interact with this subtree. For example, call some methods, find the render object or something like this. But with the same time, it's a bit dangerous because, as we discussed, they identify subtrees as a unique. So if you write something that makes the same global key appears twice simultaneously in a different places, it will be a crash because it's not possible. And with this approach, we also can move subtrees from one place to another. But it's expensive because when we move this way subtree, we take subtree, remove it from one place, and we don't know will be reused or not. So we just go through all nodes, deactivate them, and keep until the end of the frame. And then we decide, okay, it will be in another place. We take all those things and move in another place, and again activate all them. Because of this, you can keep the state of all this subtree equal to what it was and just move it into different place. But it costs. So yeah, but all those things which we discussed, they were discussed like if they in the middle of nowhere. But we work in application, and it's important to understand how it work completely together, everything. And architectural overview is a good start to this step of our talk today. So first of all, our application, it works on the top of Flutter. So Flutter by itself has a 3-layer, and our application works even higher than those 3 layers. And those 3 layers: embedder, engine, and framework. Embedder is something that allows Flutter by itself work to work on a specific platform, for example, on Android, on iOS, on web, and so on. And engine is a heart of Flutter, which manage everything, which control all processes. For example, there is also a rendering engine inside, something that actually painting things for user. And third part is a framework which we work more close, which we usually can check because it's even written in Dart and so on. That's things which we see when we work in our application as well. And all those work, they can be simplified to understand it into one short process. To describe how Flutter connect our code with something that it will be shown, it's all going this way. Engine ask framework, I'm ready to show something, give me what I need to show to the user. And framework give a representation of what to show this frame, and frame is decomposing, then converting to pixel and shown to the user. And it's happened 60 or 120 times per second. But of course, when I say the engine ask framework, it's quite broad, because even in framework there are many things. We have here material Cupertino widgets, basic widgets, rendering pipeline, some foundation animation, and so on. So of course, engine ask not everything. Engine connected with the foundation part, and with this foundation part, everything is managing inside. So to explore this, a good start point is a method which is inside this foundation part. Previously it was one method, run up, and currently it's run widget. Method run up and run widget, methods which we can use for run our application. The difference between them is not a big one, but it still exists. Run up is more preferable, and the default one and more convenient is just wrapping everything with the default wrapper. And with the run widget, you need to care about managing all those things by your own. So yeah, no big difference apart from that. And both of them operate with some binding. What is a binding? Binding is special layer, some kind of glue between that framework and all other part of between engine and all other part of framework. So and it's created as a combination of small bindings. So widget Flutter binding as a composition of other bindings. Every binding responsible for specific topic. For example, schedule building is responsible for those processes of asking frame and returning to engine. Semantic binding responsible for accessibility. Gesture binding responsible for connecting in terms of what user doing on the screen with the gesture and so on. And all of those small binding, separate binding, they are mixed scenes. And because of this, the order in which they are added to each other is quite important because it's guarantees the order of method calling inside. Let's move back to our methods with which we can start. Briefly, let's take a look at new run widget. And to be frank, I don't know how to better use this apart from using the old adapter, because previously we had this render object to widget adapter which wrap our application and connect with the special object responsible for building and for rendering pipeline. So I don't know, only this way probably it's can be used if you do not rewrite in your own way almost everything that done in Flutter. So, and the current way is run up with the wrapping with the default wrapper, default view, wrap with default view, and it's by structure it's a bit more complicated, but the core is exactly the same thing. So this wrapping which allows us to connect our application with the specific manager of building and rendering pipeline. So in both cases, end up with this method, run widget, in which we provide already our rapid application. And on this binding is run two methods, schedule attach root widget and schedule warm-up frame. What's happening there? Something like this. And a long story short, we just wrap another time around our rapid application already. So to simplify all those things, we can say that the first method end up with having three root objects: root widget, root element, and root render object, through which everything will control our application. And the second method is schedule warm-up frame. Why it's necessary? So we already discussed that framework works like asking frame, engine ask frame, a framework about frame. Frame is passed to engine. It's repeating all the time. And because we do not replace everything, we replace small parts of our subtrees. It's efficient. But in the really beginning, when we start everything, there is nothing. So we need to build from the really first widget, which we provide as a root of our application, until the end which we want to show to the user. And it's more work than any other frame that we prepared. So because of this method, Flutter doesn't wait for the first signal and starting preparing first frame before this request. And when the engine asks about this frame, some milliseconds already saved, and it helps to avoid the lag when we start application. And because of this, we can fairly say that all this construction make Flutter framework. Framework not in terms of it's big or it's complicated. It makes Flutter framework from the point of view of inversion of control, because all those things show us that Flutter completely controls our code. Not we control it. We just provide our root application widget and say run this somehow. I don't care how, but run this. Make this from this description. Make user to see something. And yeah, let's check one more thing. So I already mentioned a few times that Flutter built those frames. So 120 times per second. But building frame, it's also quite complicated thing, right? So we need to define which part of this frame is changed from the previous time, which part we need to rebuild, which part we need to re-layout, and so on and so forth. And because of this, the whole frame is split by steps. So first of all, it's updation, animation, running micro task. Then we build some subtrees updates, layouting, painting, compose everything together, push semantic, and finalizing both build and frame. So, and two of these phrases from one from really beginning and one from really end is build and finalization. Build, they are happen in a specific manager object, which we already mentioned. Now we can look at this more carefully. So it's build owner. A build owner responsible for track what need to be rebuilt next time, what is inactive currently, and help with our famous and loved hot reload, which help us develop faster. So, and it's happened with a few important methods. First of all, it's schedule build for. So this method help to mark which of element, which of subtree need to be rebuilt. Then it build scope. It's actual rebuilding those parts that need to be rebuilt. Finalization is cleaning after we finish everything, and reassemble helps with handling hot reload. So what happened when engine asks to prepare a new frame? First of all, there is a schedule building which got this request, and then start to orchestrating. And one of first and the last step is this method, widgets binding dot draw frame. So draw frame method is handling almost everything. How it's happened? First of all, we see here build owner, build scope. So with this build scope, we rebuild everything that was marked as not actual anymore. And here is a finalization that we mentioned. So both methods, both responsibility of build owner are here. Let's firstly take a look at rebuilding part. So how rebuild happen usually? So not so many options. First of all, it's build scope, which we already mentioned. When we try to insert a new composition element, as we did during example, and when we update some composition with the new possible widget. So, and actually rebuild happen in a two different way, again depending on something that we already discussed on type of those element. Is it render object element? Okay, we need to update property of render object, and then it will be handled by relayouting. If it's composition, we need to rebuild subtree which is represented by this, and depends on how it happened. It can be building from scratch or updating previous one. And the one thing which stand out is build scope. So build scope is actually entry point to start all those processes. And build scope work with the list of element which is marked as need to be rebuilt. And how it can happen that some element marks as need to be rebuilt. So deactivation to activation when we're using quite rare, but yeah. And the most possible cases, it's when concrete element is just directly marked to that it's need to be rebuilt. For example, when we start application, the root element of those things is marked that everything should be starting from its rebuild. When we call set state, in the state of stateful widget, element related to those state is also marked that this element will be rebuilt. Hot reload, and when we operate with some inherited widget, for example, because if inherited widget changed, the element which asked about value of this inherited widget can be somehow subscribed on its value, because when you operate with some widget dot of context, implementation of this dot of context often contains calling a method like depending on the inherited widget of exact type. And with this depends on inherited widget, you actually make your element depending on the value of that you use. And because of this, when value used, rebuilding will be happen. All who ask will be marked as need to be rebuilt. But between those two steps of rebuilding and finalization, we had a bunch of other steps. And where are they? And the answer is simple. Here we have only one method, super.drawFrame. And when I say that the order of mixins is important, is because of this, because with this super draw frame, we delegate all those part of rendering pipeline to another render binding. And the responsible object is a root pipeline owner. This pipeline owner is similarly as a build owner, handle what of render object need to be updated and so on, and initiate those updates. And when everything is done, we have here send frame to engine. When everything is calculated, the object is send combining. So we can see here render view composite frame. And during this composition, everything that we calculated is collected into one object specific, and this object is sent to engine. And engine can decompose those objects and already paint to user what we want. So, but those things related to layouting and calculation, the sizes and so on, they also should be efficient. So first of all, yes, we have a few rules that make it's straightforward for us. So constraints, they are going down from parent to children, and a child answers to this constraint with its size, and parent position their children. So quite straightforward. So constraints going and response going up all position. But we discussed optimization, right? Optimization for build. Maybe there is a optimization for layout as well. Yes, we have this. Yeah, first of all, when we say about constraints, we mean different constraint, but the really straightforward way is a box constraint with a minimum width and minimum height, and maximum width and maximum height. And when a child receive this constraint, it's need to take a size somewhere between those limitation. But how it can be optimized? So Flutter aims to have a linear performance layout for initial build, so there is no possible optimization apart from goes from every node one by one to another and calculate everything. But for all other things, it aims to have a sublinear layout, so make less than the same amount of work. And it can be possible with a few optimization. First of all, if child didn't mark layout, own layout is dirty, and parent provide the same constraints, child can cut off calculation on this level. How it happened? For example, there is a parent which making its layout. So it's provide a constraint to child, and first child take this constraint and say, okay, I have also a child. I provide adjusted constraints. Child 2, what is the size? Child 2 take constraints, takes this makes a decision, provides size. Child 1 also, based on those things, make a decision about its child and its size and provide it to parent. So everything is done completely. But then parent decide to recalculate layout and provide the same constraints. So instead of repeat the same amount of work, Flutter has optimization that for some implementation, it can be done that way that child 1 can say, I have the same constraint that before, so I don't need to make any calculation. At the same size that it was when you asked me last time. Apart from this, parent every time when ask child to calculate its layout, provide the value parent uses size, which by default false. And what does it mean? So if this value is true, that is mean the size of the parent depends on the size of the child. And if it's false, it's independent. So because when it falls it independent, we can say that it can be optimized. So parent provide the constraints, child decide to take some size, and then after a few frames, for example, child decided, I need to recalculate my layout, and it choose another size. But parent, if it's not depends on the size of the child, doesn't need to recalculate its layout, because parent always knows that child able to take only that size that suitable for previous provided constraint. Also, a good optimization is a tight constraint. Tight constraint is the constraint that satisfied by exactly single geometry. For example, if we have constraints, box constraints, in which maximum width and minimum width exactly the same value, we have only one width which available for us, and the same for height. Maximum height, maximum width equal the same, only one height. And because of this, it's also a lot of calculation can be dropped, because if the only one size is possible, it's the only one size, nothing more. And last thing is optimization. It's quite opposite that case when we discuss that parent ask child about calculation layout and say, does it depend on the size of child or not? So from its side, child can say that the only important thing to calculate size for its child is a constraint that provided by parent. And in this case, even if parent watch, for example, for a size of child, there is no will be additional calculation, even if layout of child for some reason is recalculated. For example, parent says to child that please calculate your layout. This is constraints, and I'm watching for your size. My size depends on your size. Child takes some size and say, hey, for me, only one important thing is a constraint that you provided to me, and if this constraint doesn't change, nothing will change. I use only one. And if it's happened for some reason, for example, because of child of this child layout recalculated, parent doesn't need to recalculate it layout because it didn't provide any new constraints. So with all those four optimization, it's also Flutter allows to make less work and be efficient on the term of layout. So that's probably it for today, and I hope you like Flutter. And if you like and want to read more about Flutter and learn more, feel free to join my channel. You are welcome there. And that's it for today. And I'm ready to answer your questions.
So for now, a chat, we haven't questions, just some time by time I share it, useful links, etc. So for now, I'll share my screen, and for all attendees, feel free to scan QR code to get your page that you attend Build with AI event session. And it seems that brings us to the end of today's amazing session. Thank you all for your participation, and it was really great to have you all here. Biggest thanks to Mikhail for such brilliant explanation of Flutter with such bright examples. We really today dive so deep into Flutter, into this amazing tool. This session was recorded as always and will be available later on YouTube channel. I'll share post with this. So you can rewatch at your convenience. And I really appreciate if you could take a few minutes to fill out the post-event feedback form. You will get email with this form at few times. So please find few minutes to leave feedback, because really your feedback is invaluable in helping us improve and make future sessions even better. Once again, thank you for joining, and see you in our next sessions next Saturday. And until then, keep learning, experimenting, and of course, building with AI.